Welcome, everyone, and I'm happy to introduce Brad Ack. Brad is the Chief Executive Officer of Ocean Visions, and he focuses on this area of intersection of science, policy, and environmental innovation. So he has a distinguished but also eclectic background. Ocean Visions, by its name, as you can tell, is very concerned with the health of the ocean, but they've recently decided that they need to venture into the climate cooling arena in order to fully explore the ways that they can restore ocean health. So I'm just going to turn it over to Brad and let him take it away.
Great. Thank you, Suzanne. Thank you, Suzanne, and pleasure to see you all. I recognize a lot of names, but I don't think I've met very many people, but I've certainly followed the various email chains on this group and the CDR group and the Healthy Planet Alliance group. So it's good to be with you all. So I was trying to think about what would be most useful to share, because obviously you're all, well aware of the depth of the problem that we face and of the types of new solutions that we're going to need in order to get out of this problem. And so I don't need to spend any time convincing anybody of that, but maybe it would be helpful to understand what role Ocean Visions is trying to play in that space and why Ocean Visions is trying to play it, and then look for places where we might collaborate going forward. So if you don't mind, I'm going to use just a few, I'm going to run through a few slides just to help illustrate some of this. So bear with me and hopefully you can see the screen.
Yes, we can.
Great. So, this is our tagline: advancing solutions for ocean climate restoration. And I'll just start there, because I think just that, might raise questions. Not very many people use the term ocean climate restoration together. There's a lot of people who talk about climate restoration, certainly people who talk about restoring the ocean, but meaning something different, meaning mostly vegetated habitats or coral reefs. We at Ocean Visions are really focused on the nexus between the ocean and the climate. They're two sides of the same coin. They're really one side of the same coin in many ways. And their health and vitality and survival is inextricably linked. So if you care about oceans, which is the starting point that we come from, you have to care about the climate crisis. Ocean Visions is a networked organization. We're very young, 3.5 years old. And this small NGO that now has 10 staff sits at the center or in the midst of a number of other institutions that have significantly more capacity than we do. The Oceanographics, Scripps and Woods Hole leading the way, but major academic institutions, Stanford and Georgia Tech and MIT and South Florida and others. And we also we call them, we're sort of evolving away from this language, but we've been calling them the Research Consortium. They're on the left side of the screen. And then we've added very deliberately organizations that are more focused on bringing solutions to life, actually taking really good ideas and vetting them, testing them, getting them through the policy process, the scaling process. And so together, we are focused around really moving innovation out of laboratories and into practice via rigorous testing and development, and then ultimately scaling. Our three major focuses are the existential threats to the ocean posed by climate disruption, supporting prolific innovation, testing, development, and demonstration of solutions, because it's going to take many solutions. Maybe some will have a much higher leverage than others, but there's no way this is going to be solved by a single approach. And we're going to need to have a much greater global community of what we call solvers and makers who are involved in this effort. why does an ocean organization focus on climate? And I already said this, but basically the ocean climate and the ocean crisis and the climate crisis are inextricably linked. And the two biggest threats to the ocean, bar none, are both driven by too much greenhouse gas concentration in the atmosphere. The first one is thermal stress. We are putting massive amounts of heat into the ocean. You all know this, but the calculation that I heard most recently from Michael Mann and the paper released a couple weeks ago on ocean warming is it's the equivalent of 7 atomic bombs of heat energy going into the ocean every second of every minute of every hour of every day of every year for the last 25 years. It's been around 7. The 25 before that, it was around 6 or 5. But it is a massive amount of heat. And that, we in the ocean conservation and science community, people always say, oh, the ocean's absorbing 90% of the heat, and then they just move on without actually asking, what is that doing? And so clearly it's a major contributor to sea level rise through thermal expansion. It's a major cause of the loss of oxygen in the ocean because warmer water holds less oxygen. And the measurements that have been done by groups like IUCN show a global average 2% decline in oxygen across the ocean, but in many places it's a much higher level than the average. We've got these marine heat waves. The most obvious effect of those is the loss of corals through bleaching. We've seen interrupted mixing between the upper layer and the mid layer of the ocean, where all the nutrient exchange happens because of this increasing thermal difference between the upper layer and the mid layer. Much more powerful storms, as all of you in California have recently experienced. The increased melt of sea ice and ice sheets and poleward migration of anything that can move. So if you compare that to plastics or overfishing or loss of marine habitat, it does not compare. These are existential and potentially irreversible threats to the ocean, while the others that I just mentioned are all reversible or mostly reversible. Yet the conservation community and the science community don't really focus on the danger that this heat poses and what we might do to turn it off. And then the second big stress is just the direct deposition of CO2 into the upper layer of the ocean, causing ocean acidification. Again, we like to sort of blithely say the ocean has absorbed 30% of the CO2 produced by humans, or somewhere in that amount. But that's a very bad thing, because it's not going into the deep part of the ocean where carbon is safely stored in a more inert form. It's in the upper layer of the ocean where it's in a dissolved format and changing ocean pH. And so we've seen, a significant change in ocean pH, of course, across the last 200 years, with a 30% increase in acidity. And so we're doing this giant chemistry experiment on the ocean that we have no idea how it will come out. But we do know that any shell-forming creatures require a calcium carbonate, and there's less availability of it as pH levels decline, and that's a big part of the base of the food chain. So we've got this enormous set of unknowns from this second major stressor to ocean health. So this is just to emphasize that you cannot solve ocean health without solving the climate problem. And you all know already the current agenda is not working. Greenhouse gas emissions just continue to grow. And every year we see a year-on-year increase in investment. And the political agreements so far have meant nothing. We know that betting on those pathways alone is a pretty slim bet, because the transitions are unprecedented. And these are quotes from the 1.5 report from the IPCC. So if we want to put all our chips in this basket, I think it's a really terrible bet. And I know you all do too. And that's why you do what you're doing. But the other part is that this idea that 1.5 is somehow a target that's a reasonable or a good target is really needs to be questioned. This is not a science target. This is a political science target, right? This was set through a political process, not by scientists saying 1.5 was safe for humanity or safe for nature. There's almost no climate scientists that would say that. They'll just say it's less risky than 2. But we know, because of these sort of the tipping elements that we're all concerned about, that even 1.5, even where we are now, holds the possibility of irreversible changes. And that's, because of things like the Arctic albedo, thawing permafrost, the ocean circulation, subsea methane, et cetera. So our thesis is we need a three-part agenda to the climate ocean crisis: reduce, remove, and repair. Reduce is this moving to a low carbon or no carbon economy. Removal is the massive amount of legacy CO2 cleanup that we need to do. And repairing is actually intervening to forestall the loss of critical parts of the system. And so this is our four-part program: reduce, remove, repair. And then we add reach because we are keenly aware that it's going to take a large global community of people across many disciplines and many sectors working on this together in order to ever achieve any kind of scale that we need. Sorry. So I'm just going to breeze through this quickly. There's a number of ways the ocean can contribute to decarbonization, primarily through blue foods and other biomaterials, through decarbonized shipping, and through new forms of ocean-based renewable energy. Wind is not the only form of offshore wind is not the only form of renewable energy the ocean can provide. Ocean thermal provides really interesting potential, as does wave and tidal energy. Moving past that, we also know that we need massive amounts of carbon removal, and we have spent most of our time looking at ways that the ocean can contribute to the kind of carbon removal at the scales that we need. And this graphic, I think, shows really well there's roughly 45 times more carbon in the deep and intermediate ocean, this 37,000 gigatons, than there is in the atmosphere. And this 37,000 is about 20 times more than all of the carbon in soils and vegetation. So as we race to develop carbon removal, ignoring the potential of the ocean, which already cycles so much of the planet's free carbon, is a mistake, but it's a mistake that we've been making. Most of the focus on carbon removal has looked at vegetative, terrestrial ecosystems and direct air capture. And so one of the things Ocean Visions has been doing is really pioneering a deeper dive into the technologies around ocean-based removal. There are a whole bunch of ways the ocean removes carbon. I won't go into these in detail, but I will commend our roadmaps to you. We built a series of roadmaps across a number of different domains of ocean-based carbon removal: ocean alkalinity enhancement, marine macroalgae, direct ocean capture using electrochemistry. There's a fourth map about to be put up there in a month on microalgae, and then a fifth map on blue carbon ecosystems. And that will cover the full array of every way that the ocean can possibly remove carbon. We also have a social license roadmap and an economics roadmap. They look like this. They're not documents. They're very interactive. If you click on one of these these big blue bubbles, you'll come to an overview of the state of the technology readiness levels, CDR potential. You click on development gaps and needs, it will highlight sort of what we know and what we don't know. And then most importantly, first order priorities. So these have been kind of fundamental to our theory of change, that we need to draw a lot of attention to the potential of this field and to the risks and the knowledge gaps, and we need to drive energy to the research, testing, and development at scale, at climate relevant scale, that needs to happen quickly in order to move forward ocean-based CDR. And so we've been working since we published these on a number of those first order priorities. We produced a research framework around macroalgae that will answer the critical questions about what happens if you grow and sink large quantities of kelp and other seaweeds. And it has sort of a minimum number of the kind of trials that are going to be needed to answer those questions. We have an RFP process out right now in collaboration with additional ventures worth about $25 million for both engineering and science on ocean alkalinity enhancement. We're working with Columbia University on a model federal law for accelerating in-water research. We've done a lot of work on messaging. We've also created a a program to work with 6 companies, and I'm happy to see a colleague from Seafields here with us today. They're one of the 6 companies. We put together teams of scientists and engineers to provide advice and review and evaluation. This is not business consulting at all. It's completely on the science and engineering side, and it's all free to the companies. And we're about to expand this program. We're building a community online called the Ocean CDR community. You can find this from our website as well. There's about 1,500 users. And we've got 2 programs under the UN Decade for Ocean Solutions. One's called GEOS, and the other is the UN Ocean Vision's UN Decade Collaborative Center for Ocean Climate Solutions. So all of that is on the Ocean CDR side, but I know you're all more interested, and I am too, on, and I'm sorry, we have a summit coming up in April in Atlanta, and we'd love to have any of you who'd like to join virtually or in person there. We will have a track on CDR, and we will have a track on this ecosystem repair that I'm about to talk about, which is the third part of this agenda. And, this is about how do you keep the vital organs of the ocean climate system alive while we reduce the fever, the planetary fever, to stretch the analogy, that's going to take quite a while to bring down. You all, I'm sure, have seen these and know about these, but these are a series of the kind of tipping elements that we're all concerned about. A number of them are in the ocean or on continental ice sheets that are directly affected by the ocean, by a warming ocean. Arctic sea ice, obviously, Greenland ice sheet, the West Antarctic ice sheet. We now know the Denman Glacier is also less stable than we thought. The ocean methane hydrates, and the Atlantic overturning current. These are all things, that are transitioning or shifting in state faster than what seems safe or prudent to allow. So the question is, can we afford not to start looking pretty deeply and intensely at whether there are interventions that are available that that might be able to be that might be effective, right? We don't know enough about these yet, but we know that we have to ask and answer these questions. And, we're looking at a range of different things like, actually, this was more an example of there are people who are looking at these different things. There's a marine cloud brightening. Here's ICE 911. You may be familiar with them. Some of the analysis that's been done around the ice sheet. I'm going to stop the slides there and just talk a little more now about what we're doing in that third area. We've just launched a program in what we're calling marine ecosystem repair and regeneration. We've just hired a person who has accepted as of yesterday this position, a person who's going to leave a tenured role in academia to lead our work on in this area. And we're going to apply the exact same model that we did to Ocean CDR. So we're going to do roadmaps, which by the way that they are the process, it engages anybody who wants to be engaged, and it tries to crowdsource knowledge from a very broad array of sources and holders of that knowledge. But we're going to do roadmaps around some of these critical tipping elements. And the roadmaps will start, and the first one will be on Arctic ice. And that's why I had reached out to Rafe, because I've known him for a while, since I was at WWF. And we were working together on Arctic 21 and other places. And the Arctic ice map will basically start with a review of all of the potential interventions that might be able to be used to slow the loss of Arctic ice. So we're not calling it refreezing the Arctic, much as I would love to see that. We're calling it slowing the loss of Arctic ice, and that's deliberate. And the range of interventions will be from the most benign, like controlling black carbon or managing fire risk above the Arctic Circle, to the least benign, stratospheric aerosol injection. And it will work just like those other maps. What is the state of each one of these technologies? What do we know about it? What are the TRLs of the technologies? What are the most critical? What is the potential scale and scope of their impact? What are the environmental and social risks and potential benefits? What are the critical development gaps and barriers? And then what are the first order priorities in terms of what's needed across a whole range of different activities to move forward knowledge of these interventions to the point where policymakers and others who hold the reins of power can essentially have information that they need to make decisions about the employability or deployability of each of these. And TRL is technology readiness level. And there's a 9-point readiness level that basically starts from just an idea all the way to a fully functioning deployed technology. So we're going to start with Arctic ice. At the very same time, we're going to do a scan of the other areas in the marine and cryosphere system that also require or merit that kind of a review. Obviously, coral reefs are the system that are most talked about in the marine conservation space, and we will be featuring synthetic approaches to coral regeneration at our summit in April. But we're starting with the Arctic because it's so widely recognized as being absolutely critical to the health and function of the planet. So that was a lot. I'll stop there and just open it up for feedback and questions and ideas and any thoughts that you have.
Okay, so this is the hard part. So please use the raise your hand. We have a lot of participants today, and you appear on 2 different screens, so it's going to be hard for me to follow. I see Robert Tulip already has his hand up, but for the rest of you, please put your hands up if you have a question or a comment, and I will try to track it, and anybody that wants to be helpful can let me know if I've missed somebody. So also, I've gotten some requests for Brad's email, which is in the Google group list, but I just want your permission, Brad, if I can post that to the chat.
Absolutely. That's just my first name at oceanvisions.org.
Okay. And I will write that down. So, Robert.
Look, thanks so much, Brad. That was just superb. Really appreciate the range of work that you're doing, which is at the cutting edge of the issues that we're facing. My question is about the security urgency, I suppose, of tipping points. And, I'm particularly worried about, this prospect that, unknown changes in the Earth system could happen really fast, which can cause exponentially accelerating feedbacks. And so for that reason, I just see, brightening the planet as something that is not on the public agenda at all. And so, putting that albedo enhancement onto the public agenda as something that the ocean is really critical for, as something that I'd really like to see you engaging with that conversation on albedo enhancement to brighten the planet and pull some of that heat out as a direct cooling agenda. Just wondering what you think about that.
I totally agree. I mean, I think we are, seriously underestimating the risks that we face right now from CO2 levels at 422 or whatever they are, but the equivalents at over 500 when you count methane and nitrous oxide and other greenhouse gases. And there's a complacency born out of that underestimation and that sort of willful, almost willful ignorance in some ways, certainly not wanting to focus on how painful of a bunch of news that is. And you would think if anybody was capable of focusing on really scary risks, it would be national security related organizations and then the military. And I think maybe they are doing more than we think, certainly in assessing these risks and maybe other countries as well. To your point, the question is, how do you begin to introduce these topics more than they are right now and give them legitimacy? And I think our trajectory with ocean-based CDR is really instructive because I left World Wildlife Fund in 2019 to basically go into Ocean Visions and start doing this work. After holding a senior position in WWF in the ocean program and trying to get that organization to focus on these topics, and there was no way. And I don't want to just call them out because there's no way the Nature Conservancy or CI or EDF or any of the big opinion leaders, quote unquote, in the space were dealing with carbon removal at all, and certainly not ocean carbon removal. And in 3 years, there is the legitimacy is much, much higher. And there's a growing community of people involved in it. And it's now considered, I would say, to be a field that's worthy for younger people in academia to think about getting into. And there's people with startups like Francisca. And, we're just seeing a blossoming because we've created a lot more legitimacy. We need to do the same thing in these areas around climate intervention and make it build a big community that will be a countervailing force against the people who will immediately react negatively and say you can't do it and you're going to destroy the planet and we can't intervene, and all the arguments you've heard. So that's one reason we call it slowing the loss of ice rather than refreezing the Arctic. Just that subtle bit of word change to me makes a difference in how people perceive it, even though ultimately refreezing the Arctic is exactly what we need to do. So I don't know if that answers your question.
Well,
but
just one little follow-up, Brad,
Yeah.
and that is on the tipping point map, Arctic methane release or ocean methane release was listed with a question mark. And I find it just really surprising and disturbing that there's such a level of uncertainty about that scale of risk, because it seems to be something that has got just such accelerating feedback risk. And so I'm just wondering if you could just comment on that and whether there's a research priority on methane in the ocean.
So first, I'll tell you, I just grabbed that graphic from our friends at Potsdam, and so you've probably seen it already. So and what's really interesting, maybe some of you participated. They and Exeter had a tipping elements or tipping points conference in September in the UK, and they spent all this time talking about these risks. And then I queried a few people who went. I wasn't able to join, and no time talking about whether there was anything that could be done about them. So even in the people who are studying this the most deeply, being able to transition to that question of can we do anything about it, it's like a mental block. There's a big project going on around permafrost thaw, led by Woodwell Climate Institute, which is a great organization and spending a fair amount of money on this question, but not going that next step to ask and answer that question. So, to answer your question, I think we don't have anywhere near the investment in the kind of risk analysis that you're pointing to is needed. Absolutely not. I'll give you another example. I was responsible for a lot of our Arctic program when I was at WWF, at least from the WWF US side. And there are thousands of scientists working in the Arctic, thousands. It may be one of the best equipped places in terms of people who study it, because it's many, many countries have Arctic science programs. And I would wager that very few of them are studying the question you just asked, even though it may be one of the highest risk things we face. Why is that? There's no social and political license and legitimacy, this is my opinion, for these questions. And so instead, they're sort of just fine-tuning our precision about the rates of loss that we're experiencing in the Arctic, and not actually asking and answering these questions. And we need to shift that.
I think. Oh, sorry.
Okay,
Well,
I have in the queue, Victor is next. And then Akeem and Robert Chris after that. Victor, look, you're muted. Victor, you're muted.
Sorry. I'm sorry.
Okay.
All right. Yeah, thank you very much, Brad. That was an excellent overview and very condensed and to the point. And I agree with everything, which is not always the case. So congratulations, compliments. And what Robert just said, of course, is also very much, it makes one desperate to try to move people. What you also said about practicing scientists not wanting to stop doing what they're doing and think a little bit further on, think a bit bigger. So I just wanted to add one little point here that people are not talking about, but which might lead to some activation. It's a tipping point, but it's not a tipping point which is of immediate concern. It's something down the road. It means that if melting continues the way it is now, and we don't stop it, what will ultimately happen is when the Antarctic continent starts melting, the continental ice, this will be due to winds, of course, warm winds coming from the oceans. Then the meltwater, yeah, I've been down there. I have been in the southern Weddell Sea and to the place, where you form bottom water. The bottom water that ventilates the deep ocean is formed there because of the salinity, and the temperature is at freezing, right? So you can't go below that. So it's the crucial point down there is the salinity. And that salinity is 34.7. I mean, it's we know that exactly, because that's the salinity of the deep ocean, the layer, the Antarctic bottom water layer has this 34.7. So you need to produce 34.7 or higher to push that water out and ventilate, provide new oxygen-rich water to the abyssal plain, right? Now, once the meltwater starts, then you won't be able to get there anymore because you'll still have ice formation, sea ice formation, you'll still have brine discharge and all that. But since the starting salinity will be lower because of the meltwater, we won't be able to hit that point. So you'll have the deep ocean, the bottom water in the deep ocean is going to start stagnating. And it'll be more or less bye-bye deep ocean benthos. Okay, this is thousands of years, right? But once we get that far, you can't stop it. There are lots of people who say, "Oh, leave the deep oceans. We can't do this." And I'm thinking in terms now of storing seaweed for sequestration. We would, of course, not just dump the seaweed anywhere. We would bale it. I'm talking from the seafield's point of view. We would bale it, compact it, and seaweed, particularly brown seaweeds, the cell walls are extremely difficult to break down. They last very long, right? And the first dikes were actually made out of seaweed in Holland. That's another story I can talk about later if you want. Anyway, so they raise all this concern. Oh, we can't do that in the deep sea, but we're going to lose the deep sea if we don't do something about it. And I just want to put this tipping point up there as well, and that is asphyxiation of the deep ocean. Thank you.
Thank you.
Brad, did you want to respond to any of Victor's comments?
No, I mean, I don't think there's much that I could add to that. I think it just, it just highlights and compounds the fact that the risks are escalating and they cascade and they get bigger the higher concentrations of CO2 and greenhouse gas as we go.
Thank you, Victor, and thank you, Brad. Akeem.
Oh, thank you. Brad, thanks. Great presentation. I put it on my list. I need to go back to your webpage. I haven't been there for about a year, so there's a lot of activity going on that I need to check out again. Not sure if you remember my name. I was one of the applicants from the X Prize to get your support, but I didn't make it through. And I then also followed up with you and asked if there are any other companies doing any cooling activities, and that was very sparse. I think there was one response, but I couldn't really see any much action happening there. So I'm just trying to get a feeling for, because a lot of us are looking into the cooling. I call it cooling, what it is. I'm a chemical engineer. That's cooling for me, what we're trying to do. The other point, but for the last 10 years, I've been working in venture capital, investing into early stage tech. And one of my first companies I invested in was a carbon CCS company out of Leeds University. Mm-hmm. It's been a long trek. It took them 6, 7, 8 years until they finally got proper funding, got people like BP and so on involved, putting money behind it. And they're only just starting to getting it up to speed. I'm trying to see comparisons here with these technologies that we are looking at. And it's very typical in hard tech areas to have timelines of 10, 15, 20 years to get something out of the lab from the ideas area into reality, into talking TRL levels from TRL 203 up to TRL 8, 9, where we want to get to. I don't think we have that time. I'm just wondering if you have any ideas, or do you see any concepts, or where is it lacking? I can see parts on the whole. You talk about risk, and I think there's a lot of perception issues here on what when we call, if you want to call it geoengineering, which is almost a dirty word from what I see in some newspaper outlets. What can we do about that? That people start looking at not at just the top line word, and that they might connect with something they've read somewhere, or might have seen in a novel, for example, Termination Shock or something like that, and that's in their head. But there are so many other solutions that address the specific heat issue. And you're absolutely right about the Hiroshima bombs. In my pitch deck, I always put every year the globe picks up 20 times more energy than we use in global primary energy. That's everything. That's coal, oil, gas, nuclear, renewables, everything together. 20 times more we pick up in heat and as part of the global warming. So it's massive. We need to do something. The chemical engineer will tell you, we need to, this is all coming in, we need to do something about it. Either we block it out or we do something internally with it and have to convert it somehow. So my question, can you see any acceleration triggers, any ways how we can drive this forward quicker? Thanks.
Yeah, I wish I had some pat answer for that. I don't, obviously, but I will say, I think we need to look at analogies in history. The most recent, obviously, is COVID, and we did things during COVID that we've never done before.
Yeah.
We had people working across borders 24/7, 365 on a whole range of different things that had to happen, whether it was vaccines or testing or different kinds of therapy or prevention. People dropped what they were doing and they worked on that issue because it was widely recognized as an emergency. So the first thing is, if we keep acting like it's not an emergency, we're never going to do what you're suggesting we need to do. And that's why, one of the things I give in my talks when I'm talking to people who are a lot less engaged than you, I say, how many of you think this is a climate emergency? And, half the people will raise their hands or maybe more. And I'll say, how many of you are acting like it's an emergency? And of course, nobody raises their hands, right? Or very few people, because we are not reorienting any of our resource allocation right now to address in any significant way to address the scale of this problem. And to your question about how quickly could something be deployed, it could be deployed a whole lot more quickly than the average sort of trajectory you talked about through a private company if governments really got behind it and expedited it, right? And made it a matter of national security to an earlier point, and national emergency or international emergency. We could do a lot more than we're doing, but how do we get it to that point? We've got to get a whole bunch of scientists who are trusted on this topic. We did a lot of research on CDR, and scientists are really the most trusted around these topics. We haven't done it for climate intervention, but we need to. Maybe somebody else has. We've got to build a much broader array of voices calling, not for the deployment, because we can't do that yet. We have to call for the testing at climate relevant scales, which is a form of deployment, but it's less scary for people than full deployment. But we've got to build that sort of critical mass and power to make that agenda happen. It's not going to happen organically, certainly not anywhere near in time.
Thanks. Just 10 seconds come back on that one. 100% correct on the COVID one, by the way. I always use that comparison. We were involved in the AstraZeneca development of the vaccine together with Vaccitech and Oxford University. What happened there? It was four unities coming together. It was the startup for the agility. It was the academics for credibility. It was the government for the regulatory part. And then corporates, large-scale corporates coming in to carry you through the operation, and then the parallel processing of doing a lot of things. And then it was about risk. How were people involved? Oh, I forgot the most important one. The institutional investors were number 5 coming into this. It was all about risk. By all these entities coming together, it became a de-risked entity. It's just everybody looked at each other and everybody suddenly was happy. Okay, let's do it. Let's do this. That's the other one. This parallel, bringing them all together at the same time, is the other one. And I stop here. Sorry, guys.
That's a great, I mean, that's a really good example. You should write that down or write it up, because it does take more than one sector, as you just said, and de-risking is everything.
Yeah.
I'm going to take that opportunity to have a short advertisement, which is HVAC is anxious for the individuals and the organizations participating in our meetings in our organization to present issue papers that we would publish on our website. So I think discussions, for instance, of Brad, the climate ocean interaction and the need for the integration of a more holistic approach that recognizes both. Again, what you just said about the structure of the work that you did, they don't need to be long. They should be documented. And if you send them to anyone in the steering circle and ask them to be considered for publication, the main rule is that they have to be professional in appearance and presentation, and they also have to make statements that can be documented. And so that's it. And Robert, Chris, you have a question.
Yeah, I did actually. Before I ask my question, I just want to make a comment following up Achim's last remark about all these things coming together. There's a very the Greeks had this notion of time called kairos, which is opposed to chronos, where everything happens sequentially. You know, this idea that time is like a river that passes along in front of us. But chronos, the kairos, is this idea that there are propitious moments, that things happen when things come together. So Leonardo da Vinci could make the initial designs for a helicopter, but he couldn't build them because a whole bunch of technologies that were necessary to make his concept real were not then available. So this idea that, you know, all the elements have to come together in space and time in order for the magic to happen is a very critical point that one needs to kind of remember. That there are lots of examples of this, and Achim has just mentioned one. But it's just a thought. The question I wanted to ask you, Brad, was really going back. It's a semantic point, really, because you made a couple of comments about the decision not to refer to refreezing the Arctic, because your feeling was that it didn't kind of it wouldn't be received correctly. I have a similar feeling towards the word restoration. Whenever I hear it in the context of climate change, I worry about it, because restoration has this sense of going back to some earlier state. And there is no going back in climate change. You know, the climate system is a fiendishly complex system, and there is no way that we're ever going to go back to some prior situation that prevailed in some sort of golden age. You might be able to restore an individual parameter to its earlier level, but you're not going to restore the climate to how it was in 1970 or 1850. So the word restoration always causes me some grief, and I wonder whether how you feel about this, and whether you feel, I mean, you've used the word, but whether you feel there might be a more forward-looking word that we could engage with, that kind of, you know, that is like has a positive feeling about it.
I think it's an excellent point, and I agree with you entirely. I use the word, but I don't like to use it. One reason to use the word climate restoration is for a popular audience, because it is a complete contradiction to net zero by 2050 and 1.5 and 2, right? Because that's just bad news and a grim and dark future. And at least climate restoration gives people some hope, but it's a totally imperfect term. I'm completely with you. I'm also a big believer in doing the communications research to find out what are the words that work. I went over that slide super quickly on the communication research we did on ocean-based carbon removal, but it's been very helpful to us in finding out the words that people really react viscerally to, and both positively and negatively. And I think the same has to happen on climate intervention. Whatever the right terms, we have to come up with the terms and the analogies. You know, it's so funny. I'll say to people what we're doing. They'll say, but what, you might harm something in the ocean with these CDR applications. And I say, if you go to the doctor and you have a infection and they prescribe antibiotics, do you not take them because you know they're going to kill good organisms in your body? No, you don't. You take if you need it, you take them. You know that there's going to be harm, and then you hope to recover later. Same thing with a cancer patient, right? I mean, chemotherapy takes you as close to death as you can be, but it kills the cancer. We've got to somehow, be able to, with some audiences, get whatever the right stories are that compare this to situations they understand in their own life, and that what we're doing is emergency medicine. I got off track on your question though, but the words really matter. Words and stories and analogies and metaphors, all that really matters. And I don't have answers for it right now, but I'd love to engage with others in doing that research.
Great. Just one further comment. Your remark about chemotherapy taking you as near to death as anything can. I've been there, so I know about
I'm glad to see you back.
that. Yeah, they didn't expect me to make it, but there you go. Thank you.
Thank you, Robert. And Rob Wheeler, you have a question.
Thank you. Yes, first, I'd like to thank you, Brad, for a fascinating presentation today. I've represented the Global Eco Village Network at the United Nations for many years, participating actively in its climate meetings and sustainable development processes, and have been following renewable energy, climate change for the past 50-some years. What you've presented today, I think, is so important that I've never heard at the United Nations a presentation on the role of climate, the role that oceans play in regards to that. And I think it's just such important work that you're doing. I'm looking forward to being able to talk about it when I go to the UN meetings at various times. I'm also working on a web portal on how humanity can transition rapidly to a fully sustainable world. I call it Sustainably Wise. Hopefully it'll be ready for a public launch by summertime. I have in our People's Global Action Campaign, and includes some of the best initiatives for civil society that they have, petition and action campaigns to make the transition that's needed. And I would love to include in there what you're doing. I'll go on your website and read about it, and I'll send you an email, and hopefully we can connect of how to continue to move this forward. Thank you so much.
Thank you. Thank you for the kind words. I appreciate them.
Super. Thank you, Brian.
Thank you, Suzanne, and good morning from the Western Pacific, where just last month we deployed a 1/4 acre of regenerative marine permaculture deepwater irrigation. It's great to see the developments here today and the community coming together. We have for years been using the framing of regenerating healthy climate, and I think that does indicate moving towards getting back to a healthy climate, but we'll never get back to the original. So I think it's really about finding those healthy climate points and enabling that to go. One minor point regarding some of Victor's comments, and that is, he mentioned that the formation of sea ice, even in a fresher world, involves the creation of brines. And I wonder if at scale, these brines could contribute to higher salinity that would in fact be bottom water that could displace a fresher situation. So I'd be interested in Victor's thoughts and comments on scaling brines and seeing where that could take us in terms of sustaining overturning circulation, if you will.
Yeah, I'm glad to answer that question. You see, the situation is that you have a coastal current flowing around the Antarctic, and this coastal current picks up, it has a certain salinity to start with, right? And it gets, the salinity increases the more ice is formed on that, on top of that coastal current. As a matter of fact, most of the ice in the Antarctic is formed around the continent, close to the continent, on this coastal current, because the ice has to form, ice formed further out to the ocean brings warm water up and that brine sinks, right? Now, the salinity that you need to have in order to reach the 34.7, it has to be higher. So if that salinity is lower, then you no matter how much ice you form, you're not going to get to 34.7, because ice formation is a bit like evaporation. You know, it's you take the water out and you leave the salt behind. So the concentration of the salt in the water that you are freezing drives this, right? So in the past, in the, years, I mean, like up to about 5 years ago, the Antarctic sea ice was actually getting bigger, right? The winter sea ice. That's not because of the margins of the ice. It's the place where the ice is being formed. And there was more ice being formed close to the continent because the winds were stronger, because the ice that forms over there has to be pushed out, right? So the ice you see in the outer rim of the Antarctic ice, sea ice cover has been formed close to the coast, right? So then you had also more bottom water formation. That's also, people are agreed on that at the moment, that you have more bottom water formation now than in let's say 10, 20, 30 years ago, because of the stronger winds. And the winds are increasing because the gradient between the ice and the open ocean is increasing, right?
Why is the gradient increasing?
Yeah, so the westerly winds have gotten stronger, and therefore you're pushing more ice out because of the Ekman drift, right? You're moving things to the equator. I mean, that whole thing makes sense, and if you explain it to people, I explain it to my students all the time, they understand it. It'll take me a minute or more, a bit more than that, to explain it all to you, but then you understand how these processes operate. And I think that's a major factor that we have to address here, is understanding Earth system science and how these things are interconnected. You have to have
the interesting note. I agree with you, Victor. That the interesting note I'd like to make is, even if your seawater is 34.5 parts per thousand, when you're making ice, which is fresh, you're also making brine, which is way over 35 parts per thousand.
That's the thing.
So at least the brine itself has the potential to displace abyssal water. Of course, the brine is a very small volume and flux, but if scaled, that is an interesting intervention to consider.
No, but that's happening. That's happening anyway, because you're always going to be forming sea ice around Antarctica, even when you have full blast global warming, because it just gets so cold there in the winter. There's no sun shining on it. The question is.
So what's interesting, I'm sorry. I think the interesting question is, could the brine formation be scaled in a way to address a freshening challenge that would stagnate the ocean? There might be interventions that would have to be scaled, of course, but it is a potential way out of the freshening problem.
No, but we have the same problem with the Greenland ice melt and the AMOC, right? The formation of North Atlantic deep water in the North Atlantic, same problem.
Yes.
Once the Greenland ice sheet starts melting in a big way, then we're going to have that problem. And that's going to lead to much colder conditions here in Europe and so on and so forth. All the
I agree.
All the other things.
And
so that's happening in the Antarctic as well. And I just wanted to point out that is going to affect the deep ocean, because at the moment, most people think, the deep ocean is going to survive. I mean, nobody's worried about the deep ocean, and we should be damn well worried. That's why I made that point.
I think it's a good point. And we do have to face the stagnation challenge with the loss of oxygen flux to the deep ocean. The challenge and the opportunity might be taking a phenomenon like brine formation, when coupled with sea ice recovery or regeneration, to actually document the amount of really cold, salty brine that could be formed and potentially could restore an overturning circulation situation. Or at least regenerate. But it's the scales are enormously different. It's just the principle at this point. But you raised some good points. I think this is the kind of thing that we'd love to take up in, maybe the Ocean Visions workshop, if you will, on regenerating a healthy climate in the Arctic. It sounds like a stimulating group, and I hope we can all contribute to that.
Yeah, I'll join too. Okay, I have another, I don't have to talk about it now, but this fear story, right? And comparing global warming and chemotherapy, you get the feeling that you're doing, that whatever intervention we do is going to cause some kind of harm. And so my specialty is iron fertilization. And when you use the word iron fertilization, people immediately start thinking about toxic algae. And that, I just tell you, that is total BS. I mean, honestly, I know what I'm talking about. I have looked at the plankton. I have my eyes always glued to the microscope when I'm doing my work in the Southern Ocean. I've carried out 3 iron fertilization experiments. This whole story of toxic algae is just a fundraising scheme. I mean, honestly, because the people who work on toxic algae, they're not going to come and say, we didn't find any toxic algae. Then they won't get any more funding. So they're in a double bind. right? So that also needs to be worked out. I mean, I'm working on a paper now to show that there is absolutely no solid proof other than the California sea lions and that one incident about domoic acid. I'm not talking about toxic algae in general. I'm talking about the oceanic toxic algae, which is a Pseudonychia genus in diatoms. I won't go into that now, but just want to say we have to blow this fear out of people. All right.
Yeah, it sounds like a elephant repellent metaphor. So thank you, Victor. Great to talk on this.
Thank you. Ron.
Thank you, Suzanne. I'm an economist, as most of you know, a radical economist. But and I wanted to. I'm trying to connect some of the themes here so far. So, I mean, in my, and I think this is shared by some of you anyway, that we have a short term and a long term crisis. So the short term, and I'd actually like Brad, your thoughts on this, because we've been focused very much on the short term, what we see as the highest priority imminent crisis, which is heating and the need for cooling. So that's where the cooling part comes in. And then the longer term, issue, regeneration and CDR drawdown, which are linked together, as because you can do that through natural means and regenerate the natural ecosystem. But then there's also, in economic terms, the energy crisis, right? So and this is where many of us have sort of and I think there is a I mean, I wrote a paper on this. There's a gap, I think, in the communities between the client scientists, screaming, and rightly so, about this disaster that's going to happen, and we need to do something. And why the hell can't the politicians get their act together and world leaders get their act together and do something? Create the emergency that we know is in front of us. So. And this divergence between that, I'm sorry, my daughter's dog is barking. The divergence between that and the politicians, if they're democratically elected politicians, they're people are focused on income, and poverty, and especially in developing countries, energy. So we have this spectacle of Ecuador drilling for oil in the jungles. Some of the most fertile jungles in the world. The previous president said, I won't drill if you give me half of the revenue I could make from drilling for that oil. And there were no takers, and so now we have they're going for it. We have the president of Mexico, buying the Shell oil refinery there in Houston, because they Mexico is also very dependent on its oil. For foreign exchange in particular, critical to developing countries. So I did a calculation. It would take about $4 trillion just to offset the foreign exchange being generated by the countries with over 10% of their exports from petroleum, and that was just oil and derivatives, because that's mostly what's exported. So without massive transfers, I don't see how we're going to get the developing countries to be able to do this. It's not that, in some cases, these left politicians would like to do this, but they have a responsibility to their people to take care of the immediate problem. So now, just to finish, I know I'm talking a lot, but so I'm particularly interested in the climate solutions, and I see Brian here, and there, Achim, I think, because we're talking about ocean, where you can try and bridge the gap here. You can do things that are good, try and regenerate the ocean, try and cool, and try to create income, alleviate the economic problem at the same time. And there's that's why I put up our list, because there's some other interesting possibilities here, like Jim Baird is not here, but OTEC, where you harvest the heat from the top layer and use the gradient, and then that heat use that to generate, for example, hydrogen or some energy, to power, and that would create by some estimates, 1.6 times all the energy that we're currently using from all sources. And then Achim, I think, has a I don't know, he's working on a method to use a cooling system that I think also, correct me if I'm, Achim can correct me, generates hydrogen. It's some way, you got to do something with that heat. You might as well harvest it and use it for energy. So so that's, and I think that's where the hope lies. I agree this notion of, we want to provide hope. And the hope is if we get to the other side, we get through the Sinai Desert, we get to the Promised Land. The Promised Land is where we have a renewable, energy and materials economy, and we can get there, and that could be more equitable and sustainable, certainly, than what we have now. But we've got to get through Sinai, and that's where we are right now. So anyway, I'll stop there.
Was there a question there, Ron?
Well, I think if I sort of, Brad and Achim, I mean, particularly these methods, what do we know about methods to cool, to generate energy, and can link these things together and to regenerate and try and do one or two or three things all together?
Yeah, I mean, I think it's a good point. I'm always on the strategic and marketing side of things, but the more people you can appeal to by talking about things that they care about, and I think we think that people care more about the oceans than they do the Arctic, probably, or can relate to it better, or more people can relate to it. The more people understand that these things integrate, and there's this, you just have to make sure you don't lose anybody in the complexity. So, in communicating it. So I'm going to go to Mike McCracken because both Roberts have had an opportunity to ask questions before, but let me go to Mike McCracken right now.
I think that was a very interesting talk. So how is what the Ocean Visions is doing in CDR related to what Sir David King is doing and the proposal he has to get some efforts going around the world to test some of these approaches?
We coordinate or collaborate with Sir David and the Center for Climate Repair. We talk on a regular basis. He's pretty focused on nutrient fertilization and on whale restoration, at least the last time I talked to him, which are some of the many pathways. Ocean Visions, I think, is taking a more ecumenical approach. We think every single one of the pathways merits full and accelerated investigation. None of them can be ruled out. I agree entirely with Victor that ocean iron fertilization certainly should not have been ruled out as it was, and it needs to be ruled back in. But they all do. There's not a single one of them that at this point in time you could say definitely doesn't work, or it's the winner. We don't know that. We do have relative sizes, scales of what they might do, and so there do seem to be upper bounds of iron fertilization. I don't want to get into a debate about what those are, but there do seem to be some. There's other approaches like ocean alkalinity enhancement that seem to have a much, much higher upper bound, but way less far along on the technology readiness, and also a lot of other life cycle related challenges associated with the large scale deployment. So our position is just do all the science testing and development as fast as possible on all of these so that we have a whole range of things to choose from. And I think Sir David's taking just a little bit different tack, although I think he would probably support what I'm saying as well.
Right. Back to Robert Tulip.
Brad, my question's about extreme weather and the role of ocean heat in worsening weather extremes. I'm particularly impressed by the potential of marine cloud brightening to target the direct sources of heat in the ocean. And so, for example, reducing the intensity of Atlantic hurricanes, which you would have thought would have been just of major interest to the USA, but apparently not. And I just find that really strange that there's a technology that has potential to reduce hurricane intensity. I'm pleased to see that we've got Stephen Salter on this call, who's been an expert on this. But Brad, you mentioned marine cloud brightening in your presentation, and could you just comment on the extreme weather agenda and how you see that?
It's way out of my area of expertise. First, I do want to recognize Jonathan because I think he is making some incredible contributions here on the marketing side. So, or on the language side, I'm going to make sure I copy the chat. You know, I mean, I think that extreme weather has the possibility of galvanizing action, like what's happened in California in the last month, right? 40 inches of rain in some areas in over the course of 30 days. The question is, how do you do that? You know, how do you take that and immediately connect it to an agenda that could do something about it? And that's hard. Maybe hurricanes are easier because you have an intervention that is more clearly linked directly to that extreme weather event. And I don't know enough about it, so I don't want to comment, but I think that would be key, that you have a technology that's really tightly linked and not something that's loosely linked, like cooling the ocean to reduce atmospheric rivers. That's a really loose link. You know, it's just there's too much terrain. But marine cloud brightening to prevent coral bleaching of the Great Barrier Reef is something people already get. And the Queensland, the Great Barrier Reef National Park and the authority are actually investigating the use of cloud brightening for moments of bleaching. So if you can get that, to me, it's getting that tight link. And then the second thing I'll say is, you know, there's this enormous funnel between people who are actually making policy and people who have information. And it goes up through people who know very little about the subject matter, right? And so people in policy advisor roles in democratic societies often don't have very much time, and they use proxies for their information. And their proxies in the environmental arena are the mainstream environmental community, which I come from, but who is woefully inadequate on these topics. And so you're not getting these conversations happening. You're not getting the information flowing up about the potential of certain interventions and why there's a lot of scientists who think that maybe it's a good idea to investigate them. That's just being cut off. That flow is being cut off. And we have to find a way to get around that. You know, now it's starting to happen. The U.S. government just passed some legislation to do the research on solar radiation modification, which is great. That took a long time to get that. There was a lot of people trying to make that not happen. Somehow, you know, we broke through on that, but we need more voices.
You just mentioned the filtering of information through ignorance. In the policymaking arena, I just would add to your players, the media. The Los Angeles Times last week ran an article saying that our extreme weather here in California, which I live in Sacramento, so I have been experiencing on a daily basis, was not caused by climate change. So, you know, when you have that kind of counter communication happening, it just makes it all the more important that we direct our messaging at the media and inform them as well. And fortunately, there's some organizations of journalists that are working on that. So, Robert, Chris, you had another question.
Yes, I want to come back on Ron's comments earlier, because he prompted a thought that I've had for a long time, that one of the fundamental problems we've got with the whole climate change discourse is the way in which it has been framed essentially as an economic problem, and that the solutions have to be mediated through economic filters and economic criteria. And Ron, you mentioned this idea of using of taking the heat from the oceans and using that to generate hydrogen, the sort of scheme that Achim is working on, and then using that as an energy source. But this of course is a great economic idea. I mean, you're taking the heat from there, which is wasted, and you're doing something useful with it. But of course, from a climate change point of view, immediately you use that hydrogen as an energy source, you have let the heat free again. You've let the heat loose again in the environment. So it becomes a completely pointless exercise from a climate change perspective. And also, by taking that position, by taking the position that I have just done, that there's no point in taking the heat out to just burn it, you're destroying also the economic proposition, because who's going to pay to take the hydrogen out and do nothing with it? So there is a fundamental problem that we come up against all the time here, which is the economic criteria that are used to make decisions about climate change. You talked about the short-termism, understandable. This is not a criticism, but the understandable short-termism of governments who are concerned about the here and now, looking after their people, and they're going to make those decisions in the here and now. Achim mentioned the COVID crisis and how things all came together. The reason they all came together was because people were dying there and then in developed countries where the money and the power resides. And so that would prompt action, but people are not dying in great numbers in the jurisdictions where the rich and powerful reside. Most of the people that are suffering from climate change at the moment are in other places, right? There's some people in California having their homes burnt down, which has been unfortunate, and people in Florida are suffering from storms. But by and large, that isn't the case. And so there is this, the timing has not come together yet. We need, unfortunately, to have more grief, more pain, more suffering, more disasters before people will wake up. And of course, by the time that happens, it'll be too late to do much about it because of the inertia in the climate. So the point of this comment really is just to, and it's really for Brad as well, is there any way that we can break away from the restraints and the constraints of this economic framing? I'm convinced that in years to come, if there are any people left, and they're writing the history of this age that we're living through now, that one of the real baddies that's going to come through is William Nordhaus. He's going to be the bad guy. And, you know, I'm not quite sure how we deal with that in the here and now.
So again, outside of my area of expertise, but I'll just offer two thoughts. One is that we do break free of the constraints of conventional economics every time we come up against something that's declared of strong national interest, right? Like wars, we print money and we do whatever we have to do. COVID. So it's certainly possible that we could establish that kind of an emergency. We could nationalize the oil industry. It's been done before. It's not even radical to think of that. You know, when you actually consider it. I'm sure you've all read the book or seen it by Kim Stanley Robinson, Ministry for the Future, but I loved the piece in there about creating a new global currency backed by federal banks tied to tons of carbon removal. The only way you get any of that money is by removing carbon, and it's actually a currency backed by something of value. So, you know, maybe there are hacks in that arena that, you know, smarter people than myself would know how to figure out. But it does seem like you're going to have to either transcend economics through an emergency declaration, or you're going to have to employ economics through valuing the right things and charging for the wrong things.
It's amazing that everybody's so attracted to cryptocurrency, which seems to be not connected to anything of value. Michael Kraken, did you have another question? Your hand's up.
Yeah, I actually want to come back to comment on what you were commenting, Suzanne, about this issue of atmospheric rivers. Yes, there have been atmospheric rivers in the past, and they do occur. Jerry Namias of Scripps quite some time ago basically tried to make the point that they were steered by ocean currents, by gradients in ocean temperature that occur, which you know, align most of the time to send a lot of the rainstorm sort of up to the North Pacific Northwest or something like that. But at other times get aligned and sent it into California. But basically ocean currents seem capable, gradients in ocean temperatures, I should say, seem capable of basically helping steer where those currents go. And so the question becomes, and you know, it's been suggested, and I don't know, is that you create gradients to try and steer some of these systems if you can. You might want to, the trouble is once you steer them, you get what happened in California, which is a drenching. But there is the question, for example, for Australia, where the main storm track is moving south of Australia. So the agricultural areas of southern Australia just have very little rain. About whether you could create a gradient that affects the storms that occasionally come in from the Indian Ocean and across southern Australia to try and provide rain at least sometime to the traditional agricultural region there. So there is the issue of trying to maybe do some things with the ocean that might provide some sort of benefit. I mean, that's why the state of Australia, Victoria, Australia, put in support for the climate engineering conference we did at Asilomar in 2010 or something like that, and stuff. So there are things you can maybe do in affecting the gradient of temperature that you might do by marine cloud brightening or something that might ultimately create trends in steering storm tracks. So,
well, and
I mean, I must say that we're coming out to ski on all the snow that's in the mountains sometimes. There are some benefits, yeah.
Well, and we started talking too about, you know, the movement, the need for movement, because some of this is just getting stuck. Weather patterns are getting stuck in one place. And so, you know, moving them along, you know, would be something very helpful as far as we're concerned. Ron, I'm just going to note that it's 2:52 in my world, which means we've got 8 minutes left. So I'm going to let Ron ask his question, and then Brad, turn it back to you to follow up. I do want to say that we will be posting the recording on the website, as well as Brad, if you will send me your slides, I will be posting those as well. I put Brad's email into the chat, and also as well as the Ocean Visions website. And as for anyone who's new here or doesn't routinely get our notifications, please put your email in the chat or email it to me, and I've put my email in the chat, and we'll get you included. So Ron, you're muted, Ron.
Thank you, Sid. I'm thinking if Stephen Salter is here, it might be good, because I apologize for diverting the conversation to economics and so forth. I can address those questions, but I think this issue of, as I recall, Stephen has this method of trying to actually address those gradients and where the storm systems happen, and maybe many of you are familiar with that, but I don't know if Stephen is still with us, or if
yes, he is. Stephen, did you want to make some comment on that? Just need to unmute. There you go.
Yes. The CSIRO, the Australians, have published some information about the Indian Ocean dipole. This is the difference in temperature east and west across the Indian Ocean from Africa to Australia, and that affects the precipitation on either side. So it's just as important to understand the temperature difference, the gradient, as it is the actual absolute value. And I've got some calculations about how many vessels you need to move this by how much temperature difference, and I will send them to anybody who's interested. The thing about the hurricanes is that you want to do it over the whole of the Atlantic, between the Gulf of Mexico and the African side of the Atlantic. And what you'd want to do would be to have ships that were cruising that area starting at the end of the previous hurricane season, and we have satellites that would measure the temperature across the Atlantic there, and would either increase or reduce their activities according to the wishes of the governments around the Gulf of Mexico who would be affected by hurricanes. Nobody's going to be brave enough to say, we promise you'll never have another Category 5 hurricane. But what they can do is they'll say, we try and make the temperatures be values that you'd like to have, and you can pay us according to how close we get. And this would be a way to pass the buck of the responsibility for what happened with these temperature gradients to the governments. I think probably you'd want to reduce them by 2 or 2.5 degrees, and you need a few hundred spray vessels to do this, provided that they were working all the time. You can never stop a hurricane that's going to happen next week. You're much too late. You should have started last November.
You can steer the hurricanes up the Atlantic so they come across to the UK. That would be delightful.
They do that. They turn to the right. There's a tendency for them to turn to the right. and we do get the residues of violent winds after a hurricane's been doing all this stuff off Florida.
Okay, one last comment, Brian, before I turn it over to Brad.
Well, I think that it's a great comment, and I would encourage the notion of prizes and performance contracts to aim to achieve healthy climate goals. The role of governance, the role of governments should be to govern as opposed to do it themselves. And by establishing the right economic conditions, I think we can develop scalable and safe approaches to regenerating healthy climate.
There's one other thing I'd like to add, by the way, which is you can do rough estimates of the cost of the number of vessels that you can have to make. And you can base these either on what corvettes cost back in 1940, or you can base it on the present day costs by weight and power of heavy earth-moving machinery, which are quite like the power generation that we want to use. If you do that, it looks as though the annual cost of owning the fleets is lower than the cost of having COP meetings. The estimate
that makes a lot of sense.
The estimate for security for the Glasgow COP was £250 million, just for the police in Glasgow. Now, if you've got bigwigs coming across with their security from the United States, it's going to be a lot more on top of that. So it's really pretty safe to assume that the cost of this is zero comparison with the costs of the hurricanes in a season. So forget what it's going to cost, because zero is a very accurate estimate.
That sounds good. We should do a virtual COP and have all the funds go to climate repair.
That's right. Yeah.
I know. So great. Brad, I'm going to give you the last words here before we break up.
Thanks. I don't have much to add. I've spoken a lot, but it was a great conversation. I really enjoyed it. If you're interested in being part of this, of any of our work, and especially this Arctic ice question, please join our mailing list. We only send things out once a month, maybe twice at the most, so you don't get bombarded. We don't ask for money, but it's just a way to know when there's going to be a workshop or when there's a call for information. And also love to have you come to Atlanta in April and join us face to face with a lot of other people and having the very conversations that we've been having today here that are very stimulating, and we need a lot more of them. So thank you for your time and your interest.